Last page. Last page. We've got 3 problems to solve. Looking at the first one, this one's very easy to factor if you want to do it that way. Just pull out an x, you'll get x equals 0 and x equal negative, or positive 9 rather, for this one. Over here, add that 7x first. We get 2x squared minus 5x. Subtract the 6. Minus 7 is equal to 0. On this one, it's going to factor out 2x minus 7, x plus 1 equals 0. So you'll get x equals 7 over 2 and x equal negative 1. Again, you can do this in the calculator. If you're looking for that video on how to do it on the calculator, I think it's the 3rd page that we start doing that. Yeah, it'll be the 3rd page to look at that. I've got a couple examples of how to do that. On this last one, subtract the 3 over. X squared minus 2x minus 3 is equal to 0. You've got x minus 3, x plus 1. So x is equal to 3, x is equal to negative 1. There we go. Last part of it. Now you will have a few of these on the test. Remember that in a square root, you've got to have 2 of the same number to be able to pull them out. Example, if I have the square root of 25, 25 is 5 times 5. I've got 2 5s in my factor tree on the inside. I got to pull that 5 out, and you'll just have a 5. All right, 2 on the inside, 1 on the outside. What you want, preferably, is to pull out the largest perfect square, because as soon as you get a pair, you can pull it out. You don't have to break them down further. As soon as you get that pair, you can pull it out. Now, if you don't find that largest perfect square, it doesn't matter, and I'll show you on number 41. It's just faster if you can. Example, 106. Why did I use 106? Well, because 100 is a perfect square. This is 10 times 10. All right, 6 breaks down into 2 and 3. There are no more pairs in that, so it's just 10 square roots of 6. Or if you were doing it the long way, 10 squares of 2 times 3, again, is 2 times 3. 10 squares is 6. But we already knew it was square root of 6. So what if you did not know that 100 was a perfect square? What if you did something crazy? So let's say we've got the square root of 600. All right? And you did not know that it was 6 times 100. You said it was 2 times 300. And 300 is 2 times 150. And 150 is 2 times 75. And 75 is 3 times 25. 25 is 5 times 5. Now this is a lot of craziness. However, you can still go about it. Look, a pair of 2, I've got a pair of 5s, so I've got a 2 that comes out, I've got a 5 that comes out, and on the inside I've got a 2 that's left and a 3 that's left. Lo and behold, same answer. Well, of course, it's the same problem. So it doesn't matter if you go about it the fast way. I'm going to try to pull out the biggest perfect square I can each time, or if you go about it the more time-consuming way, by breaking it down as best you can. So some of you will be able to see that, some of you won't. Just, it's all in how you approach it. So when we look at number 42, I'm going to pull out a 16. 16 is the largest perfect square that I could think of that would go into that. 16, of course, 4 and 4. Pair my 4s up. 2 and 3, there are no more pairs, so I'm going to leave that 6 on the inside. I had a 12 that was already outside of my radical, and that's going to get multiplied by the 4 that I pulled out. And of course I've got the 2 and the 3 still left on the inside, so 48 square roots of 6. Looking at number 43, 25 comes to mind as the largest perfect square. So I've got 25 times 10. Your letters, I just write out, I've got a times a times a, that's a cubed. That's how I'm going to break that one down. I paired up my 5s. I'm going to take one pair of a's, so I've got a 5 that paired up. Of course you can break the 10 down, but no more pairs. An a that pulled out, and of course my 2 and my 5 that are left on the inside, and my a that's left on the inside. So 5a, square roots of 10, a. All done. And that's how it goes. That's how the radicals work. Good luck. Last test, domination time.